So we are going to look at almost a circle. So the first task, we're told to write a class called base. Then, before you have to create empty file called init.py. Just do all these things. Then inside this class, we are to create a private class attribute called MB objects, meaning number of objects. Then we use a class constructor to create call class constructor, and then inside this class constructor we have to make sure that if id is none, we assign a public instance attribute id with this argument as value, and then otherwise we increment MB objects by 1 and assign the new value to the public instance attribute. So let's get started. So first things we do, as we've been asked to define a class private attribute called number of objects and initialize it to 0, and then the private attributes are prefixed with double underscores. I guess you know that already. So next is to define a class constructor that takes self and optional parameter id initialized to none. So init that takes self and optional parameter id and is initialized to none. So inside this constructor, we are told to check if an id is being provided whenever a base model instance is being created. So we check if id is provided. If it's provided, we are going to assign the value to self.id attribute. So we say self.id is equal to id, which means a value was provided. If a value was not provided, but we've been told to increment the private class attribute by 1. So we call the class followed by the private class attribute, that is number of objects. We increment it by 1. So, and then after incrementing it by 1, we are told to assign it as a value to self.id instance attribute. So we say self.id is equal to this, the class attribute. What this is going to do is to assign a unique ID to each instance that is created from the base model class, starting from each new instance or object. So like this, where we are creating the instance of the base class, and then we are going to print it. So this one is going to have ID 1 because we created it without passing any value. So it's going to increment the class attribute by 1 and assign it to self.id. So it's going to be 1. So we created this one without another value, so it's going to increment it by 1, which is 2. This one is output is going to be 2. Same thing with this one, output is going to be 3. For this one, it was created with the value, so the ID is going to be 12, and it's still going to increment the base. The class attribute is still going to be incremented by 1. Is it? No, it's not. So their class attribute is still going to be remain 3, and this one is going to have the ID of 12. And then for this fifth one, once this one is created without an ID, So it's going to continue from here. This one was 3. So once we create this one without any value, it's going to be incremented by 1, which is going to make the ID 4. So let's run it and see. So it's the first one is 1. This without value, the second one without value, the third one, and the fourth one we passed in 12 as value. So he has the ID as 12, and then the fifth one he didn't pass any value to it. So he continued from where he started, which was 3, and now is 4. So so for the second one, we're told to write a class rectangle that is going to inherit from the base class, and then in this file rectangle.py, the class rectangle inherits from base class and is going to have private instances with their own public getter and setters, width, height, x and y, and then it's a class constructor with all these parameters. And then inside the class constructor for rectangle, we are going to call the superclass with ID. So we are going to use the same logic of the init method of base class, and then each argument, width, height and so on, we assign the right attribute. So let's get started. So I've already imported base from base class. If this does not work for you, I think you can go from models.base import base. So I believe this should also work. Then I've already created the rectangle class, passed in the base model, which means rectangle is going to inherit from the base class. So the next thing to do is to create the constructor. So we pass in self followed by width, height, s with value 0 and y with default value 0, and then the ID from the base class, we also pass it in here, and then we are going to call the constructor of the parent class, which is base. So we call super dot init, and we pass in ID. So this will initialize the ID attribute of the rectangle instance by invoking the constructor of the base class. The ID attribute is set based on the logic in the base class. In this way, we can ensure that the base class initialization logic is executed when creating a rectangle instance, and the ID attribute is appropriately set based on the same logic in the base class. The same logic where once an object is created or instance is created, the MB object is going to increase by 1. If another one is created, it's going to increase by 2, which means all of them are going to have different IDs. So it is a common pattern when working with class inheritance in Python, where you want to reuse the behavior of a parent class in a subclass. So next thing is to assign the values to all the parameters, that is self dot width equal to width. We do the same for self dot height, which represent the height of the rectangle, and then self dot x, which represent the x coordinate of the rectangle, and self dot y, which represent the y coordinate of the rectangle. So the next thing you have to do is to use a getter and setter method for all the instance attributes. So we say start with which one? Start with width. What is this called again? It's called encapsulation. So we start with width, passing self, and then we return. Make sure they are all private attributes. Self the width, and then for the setter, we do width dot setter, def width, passing self, and whatever value that is going to be passed when the instance of the rectangle is going to be created. So we are going to set self dot, what are we going? Okay, self dot width equal to value. So I'll just copy this 3 times, so we can do the same for the rest. One more time. And then for height, setter for height, and then setter for x, height. Okay. For x, for x and for height, for y, for y, for y. I think I got it all. So what else? I think we are done with what the task asks for. So next thing is to, let's test this. So we say I'm just going to type out this one and fasten it, so you don't have to watch me do it. So now that we've created the instance of the rectangle class, and then we are going to print out all of their IDs for rectangle 1, rectangle 2, and rectangle 3. So before we print it out, I want you to know that this is going to use the same logic as the base class. Whenever an instance is created, the number of objects is incremented by 1. So if we create this one, if we print this one out, it's going to be 1. If we print this one out, it's going to be 2, because here we only pass the argument for width and height, and then these ones we didn't pass for x and y, we didn't pass for id. So it's going to return the logic for the base class. And then for the third instance that we created here, we passed width, height, x, y, and then we passed the value for the id. So this one is going to have id of 1, this one id of 2, and this one is going to have id of 12. So let's run this. Rectangle.py. Let me see. Save that. Okay. Def x, then return self.x, then x dot setter I thought I got it up. So you see, this is 1 because we pass no value to it. This is a value for the ID. Same thing with this one. This one is 2. It's incremented by 2. We pass no value for ID. And for this one, we pass the value for ID, which is 12. And then the ID is 12. So I guess the third one, we have to update the class rectangle by adding validation of all setter methods and instantiation, ID included, that if the input is not an integer, we raise this type error, and if width or height is under or equals 0, we raise the value error. If x or y is under 0, we raise the value error, which means s and y can be equals to 0. So continue from where we stopped, let's go to width setter. So first we are going to use this instance to ensure that value is an integer. So we say if value is not an instance of an integer, if value is not an instance of an integer, we are going to raise a type error saying width must be an integer. And then we are also going to check that the value is a positive number. So we check if value is less than or equal to 0, which means if value is a negative number, we are going to raise the value error. With the message width must be
greater than 0. Then if both checks are passed, we set the value of self.width. We just set self.width as the value. So we have to do the same for all setters except x and y, which can be equal to 0. So I'm still going to copy this. I go to height setter. Now paste it there. Take this one out. I wasn't supposed to copy it at the start. Then I'll go here. So make a little modification to this one. Then we copy it again. Go to the S setter. And we paste it. And then we make another modification, x. For this one, x can be equal to 0. So this is x, and then we go to y setter and we do the same thing. And this is x, this is y. What does this say here? If x or y is under the 0, say x must be greater or equal to 0, same thing with y. Okay, greater or equal to, yeah. So that is it for this one. Let's save and run. As you already know, down here I have all this what was provided for the test. I have it in inside of my main. So I'll just save and run. Yeah. So let's go. So for the fourth one is when we are told to update the class rectangle by adding the public method def area, and then it has to return the area value of rectangle instance. So I guess this one is pretty forward. Just come to this part and create a method called area. It's going to take self, and then we say area is equal to self dot width multiplied by self dot height, and then we return area. So as you already know, I always add a test file inside the main. So save and run. Okay, so let's go to the next one. So for the fifth task, we are told to update the rectangle class by adding public method called display, and then inside this display we are told to print to the standard output the rectangle instance with the character hash. Then we don't need to handle x and y here. So this is my display method. So to print the size of the excuse me, to print the size of the rectangle with the hash character, we are going to use a for loop. So dash in range, and then we are going to pass self dot height, because what we are told to do is to print the size of the rectangle using hash. So if we pass in height, we are sure that height is vertically. So like here, height is 6. We know that the line is going to be 6 lines vertically, and then we are going to print the character hash horizontally, that's going this way, into the size of width. So since width is 4 here, so it's going to print 1 2 3 4, and it's going to move the next line to the next line 1 2 3 4, to the next line 1 2 3 4, that's the third line, to the next line 1 2 3 4 2 3 4 3 4, until it gets to 6 lines. So let's save it around. There you see. So the width is 4, it prints hash 4 horizontally, and then vertically is a 6 line. There for the second one, width is 2 and height is 2. So let's go. So the sixth one, we are told to update the class rectangle by overriding the string method, so that it returns a string representation in this format. For example, it's going to say rectangle, I think this is the ID, and it's going to say 2/1 minus 4/6, 4 being the width and 6 being the height. So this is I'm already inside my rectangle class. I've already defined the function. So this string method is just a special method in Python. It's used to define a string representation of an object. So whatever way you structure it here is going to show like that when you want to print just the instance of an object. So let's follow the format: rectangle followed by ID. Okay, rectangle followed by ID, and then this slash this subtracted by this slash this. So we use the format method. So I guess the first one is what ID xy width height. Okay, self dot ID self dot x self dot y, yes, self dot width, and self dot height. Self dot height. So let's bring this down. So let's save and run. There you have it. So for the seventh one, we have to update the class rectangle by improving the public method def display. So to print in the standard output the rectangle instance with the character hash by taking care of x and y. So for us to do this, we have to know that the y character it represents the space that is going to be printed horizontally, just straight, and then the x character represents the number of spaces to be printed vertically, then followed by the size of the width, then to the size of the height of the rectangle. So y represents space horizontally, x represents space vertically. So we are updating. So since y represents the number of spaces to be printed horizontally, we are going to first print y number of spaces using a for loop. So we say for session y, we are going to print the number of spaces to y, or let's y to the numbers into the number of spaces. So whatever y is, we are going to print space, and then we are going to modify this other loop so we can be able to print x number of spaces vertically, followed by the hash character to the size of the width. So what we are going to do here is just made a little modification here. We are going to print space into the size of self.x, and we concatenate it with hash into the size of the width. So like for instance, this 2 is width, so there's going to be 2 hash by the side, and 3 is the height, the length is going to be 3, and then the x is 2, so there's going to be 2 spaces by the side before the width is printed, and y is 2, there's going to be 2 spaces at the top, another 2 spaces at the top before it's printed. Then for this one, there won't be no space at the top because y is 0. There will be only 1 space by the side because x is 1. Let's just run it and see. That is it. Since s is 2 for the first one, 2 spaces at the top, and then y is 2, 2 spaces at the top, and x is 2, 2 spaces beside, and then here y is 0, no spaces at the top, and x is 1, and then there's just 1 space at the left side. So the 8th task, we are to update the class rectangle by adding the public method update, and this method is going to receive some unknown number of arguments. Then we are to assign an argument to each attribute. So the first argument is going to go to ID, second one to width, third one to height, just like that. If there are only 3 arguments, the 3 arguments should just go to the first 3. Okay, so To assign the arguments to the attributes based on their position, we first check if there is at least an argument that is passed. So we check if the argument is not empty. If it's not empty, we are going to define a list of attributes in the order that they should be updated. So we say attribute is equal to, we're going to be a list. First one is ID, second one is width, third one is height, height, fourth one is X, fifth one is Y. So we are going to loop through the attributes and assign them values from the arguments. So we say for I and the attributes in enumerate. So we use this enumerate instead of the range method, and we pass in attributes. So this enumerate is going to attributes. This enumerate is going to loop through the attributes. So it's going to be returning the index followed by the value, that is index 0, which is I, and then value ID, just like that. So next we are going to check if the current index is within the number of provided arguments. So we say if I is less than the length of argument passed. So we are going to, if I is less than the argument passed, we are going to use the search attribute function to set the attribute in the self object to the argument value, like this. Say set attribute, then first we pass in self, as we are dealing with class, and then we pass in the attribute, that's the attributes that we created, that's the list, each attribute inside the list, and then we pass in the args. That is, for the first element in the attribute in this list, we are going to pass to it the first argument that is passed to the function. For the second one it follows, for the third one it follows, for the fifth one it follows, until I becomes less until I is now equal to the length of the argument passed. If the argument pass is 3, and now if I is 3, then it's going to stop. So let's save and run. Made a mistake. Set. Yeah. Or we can do this other way. We can use this. We can use another way to go about this one. So let's use for loop together with enumerate. So let's say for count again enumerate, and then we pass in args
So what this is going to do is this for loop is going to iterate over this iterate the arguments in the number of arguments that is passed. If the argument passes 3 times, the for loop is only going to go 3 times. If it's fourth, it's going to only go 4 times. So the argument these arguments, these args, is typically a tuple and is also indexed just like a list. So when the for loop iterates over the first item, count will be 0, just like this. If you iterates over the first item, count is going to be 0. So we say if count is 0, which is 0 is the first argument that's passed. So what we are going to say is that since now the count is index 0, meaning that the first argument belongs to id, so we say self.id is equal to arg. So this will take the first argument passed and give it to id. So remember that the first argument should be id attribute. Now, so if count is 1, so we do elif count is 1. Now if count is 1, we assign this, which is the second attribute, the second argument that is passed, and the second argument is supposed to pass it to width. So we say self.width is equal to arg. So just like that, if count is 2, which means is the third argument. So if count is 2, we assign the value of the argument to self.height attribute equal to arg. So again, we check if count is 3. If count is 3, the next one should be, I think we've done id with, it should be x. So we say self.x is equal to the arg. Again, we check if count is 4. That's the fifth argument on the list, in the tuple, which is the argument passed. So we say self.y is equal to arg, and then we say else. So now if the count is greater than 4, which is by index, if it's greater than 4, meaning that if by mistake or by a deliberate act more than the needed arguments were passed, we are going to use continue to skip to the next iteration of the loop without making any assignments. So we just say continue. So whenever the for loop is done running, it's going to come out of the loop without making any other assignments. So let's save this and run. Yeah, so I believe we got the same output or not. So that's another way to go about it. So the ninth one, we are to update the rectangle class by updating the public method update. So we are to change the prototype, then make space for the keyword arguments that assigns a key value per argument to the attributes. So, and we are to make sure that if the keyword argument must be skipped if the multi arguments exist and is not empty. Okay. So this is also the expected output. So since let's just first we pass in the keyword arguments, and then we are told to make sure that we get to the keywords argument if only the multi arguments were not passed. So we say um, say if asks, uh, let me move this. Yeah, and then we elif say elif the length, because we want to make sure that the keyword argument is not empty. So say that the as must be greater than 0, which means there is an existing keyword argument that's passed. So we are going to look through both the keys and values passed. Say for key, which represents the key, and value, which represents the value in the keyword arguments dot items, and then we are going to say if the key is id, if key is id, you will say self dot id equal to the value, the associated value, and then we say elif key is equal to read, then we say self dot the read is equal to the associated value as well. Same thing we are going to do for all of them. We say if key is equal to, which one is following, is equal to height, we say self dot height is equal to the associated value, and then we check if the key is x, then we say self dot x is equal to the associated value, then just say elif the key is equal to y, then we say self dot y is equal to the associated value. So we can either continue or just break out of it. So let's save it around. Let me see. Okay, so for the 10th one, we are told to write a class square that is going to inherit from rectangle, and then create a constructor, and then inside this constructor we call the superclass with all of the parameters from the parent class, and then it's going to use the same logic of the units of the rectangle class. And then for this one, we have to change the value of width and height as size, and then we are not to create new attributes. Then all width and height size validation must inherit from the rectangle, and then we should override the string method to return the square class in this format, the representation of the square class in this format. So I've already imported the class rectangle and then created the square class, and then my docs, and then the constructor. So normally we are supposed to create the constructor like this. It's usually like this. We just say width, and then we pass in height, then we say x equal to 0, say y equal to 0, and say id equal to none. And then after passing all the parameters from the parent class constructor to the child class constructor, we are also supposed to pass it, call the super, and pass it to the super, like and then we still say width, height, x, y, and id. So this is how we're supposed to do it usually, but since we are told to replace width, this width and height with the value of size, so already up here it has to be size. So since we are told to replace width and height with size, we just you remove this width and put size there. Same thing, we remove height and put size there. So this is going to ensure that we can still use self.width and self.height in the square class, but they will have the same value due to how we set it in this constructor. So next, we are told to define a special string method to override the string representation of the square class. So we say passing self, so we just say string representation. So we just return the first one is self.id, self.x, self.y, self.width. Okay, let's set this. Yeah, then over this and this. I think this is it. So square, yeah. So let's check, let's save and run. This is the test from the main. So I just added it to my main instead of creating another new file. Yeah, don't forget that since the child class is inheriting from the parents class, it's going to print the size of the square in the same manner, the way that we set it in there. So I think I'm going to divide this video into two. This is going to be the first part, and then the remaining 11 tasks, I'll move it into the second one so it doesn't become too long. So watch out for part two, they'll say.